In this video, we'll look at graphing a plane using intercepts. The equation of the plane is 3x minus 4y plus 6z minus 12 equals 0. And we'll want to find the x, y, and z intercepts. So, start with the x-intercept. For the x-intercept, set y equal to 0 and z equal to 0. And when you do that, you get 3x minus 12 equals 0, or 3x equals 12, and so x equals 4. And so my x-intercept is 4, 0, 0. For the y-intercept, you'll set the x equal to 0 and the z equal to 0. In which case that becomes 0, that becomes 0, and you're just left with negative 4y minus 12 equals 0, and negative 4y equals positive 12, and y equals negative 3. And we'll go up here. For the z-intercept, we'll set x equal to 0 and y equal to 0, and we get 6z minus 12 equals 0, so 6z equals 12, and so z equals 2. Oh, and I should write, here we have the y-intercept is 0, negative 3, 0, and here we have the z-intercept is 0, 0, 2. Okay, time to graph. Get out my trusty ruler. Usually when we're graphing on a two-dimensional surface, like a piece of paper, something that is a three-dimensional shape, like a plane, we'll make this axis the y-axis, this one the z-axis, and on a diagonal, think of this x-axis as coming out of the page at you, which of course is hard to do visually, but that's going to be our representation. And now we'll need to label the scale. I need to go up to 4, so I think I'll make every tick worth 2. I gotta label all the axes too. That is, I gotta put ticks on each one, including the x-axis. It needs its own set of markers for where each value is gonna be. Make sure to put these little ticks. And now label them. So this is y of negative 1, negative 2, positive 1, positive 2. Oh, and y needs to go to negative 3. I better make sure I have one more tick there. Just made it. Negative 3. And then, oh, I was going to go up by 2's. Well, can't do that now. I'm going to extend the z-axis here. Let's extend that z-axis a bit upwards. And this was a tick, so now here's one. Okay, so z goes 1, 2, 3, 4. I'm going to erase that cleanly. Go. And here, negative 1, negative 2, negative 3. And then the x-axis comes out 1, 2, 3, and goes back negative 1, negative 2, negative 3. Okay. The x-intercept, oh, the x-intercept comes out to 4. Okay, I better extend that axis too. Good thing I'm using pencil. I can't stress how important it is to be able to show good communication. And if you make a mistake, no problem, just erase it and fix it. And here we are at x equals 4. Alright. So we've got an x-intercept of 4, put a dot, a y-intercept of negative 3, put a dot, and a z-intercept of positive 2, put a dot. Connect them. You're going to notice, obviously, the shape you get when you connect any 3 points is a triangle. Planes are not triangles, they're infinite in all directions, but for representation purposes, so we can kind of see it, we'll shade in this triangle, make sure I can still see your scale. And this is showing a plane, but really it extends forever in all directions along this surface. And that's our representation. It's not complete though without one other thing, which is to visualize, okay, if you hit the x-axis here, and the z-axis here, and the y-axis here, visually, is the origin behind the plane or in front of the plane? And so for full marks, you must indicate near your graph or right adjacent to it, the origin, in this case, is behind the plane. That's part of your graph, this explanation, this sentence or phrase, that when I make this plane here, this is above the origin, here this is out in front, and this is on the left side. So as this plane extends out, the origin will be behind the plane. And we've done it. We've graphed a plane using the x, y, and z intercepts.